In the last video, we asked a question that seemed simple at first. Why does multiplying two negative numbers give a positive? And the answer reveals something surprisingly geometric. A negative number wasn't just a symbol. It was an instruction, a reversal, a flip in direction. Multiply by a negative once and the orientation reverses. Multiply by a negative again and that reversal reverses itself. Two flips restore the original orientation. That was the explanation. Elegant, satisfying, complete, or so it seems. Because hidden inside that answer is a deeper question. A question so familiar that most people would never stop asking for it. Because if multiplying two negative restore direction, then what happens when a number multiplies itself? Why does squaring seem to erase direction entirely? Take positive 3, square it, and you get 9. Take negative 3, square it, and somehow you get exactly the same thing, the same result, the same magnitude, and the same sign. So no trace of where the number came from, no evidence that one pointed right and the other pointed left. Somehow the operation has forgotten orientation itself, and that is deeply strange because positive and negative are not just more differences, they are opposites. They encode entirely different direction in mathematical space. And yet under squaring, the distinction collapses completely. Why? Where does that information go? How can an operation begin with opposite direction and end with perfect agreement? It feels like arithmetic is more like disappearance, as though squaring reaches into a number and removes something fundamental. But that is not what is happening, because the truth is far more beautiful. Squaring does not erase direction, it resolves it. And to understand why, we need to understand what numbers are actually doing when they multiply, because multiplication is far stranger than it first appears. We were taught to think of numbers as amounts: 3 apples, 5 books, 10 meters, static objects, things to count. But this picture is incomplete. Numbers are not merely quantities, they are transformations. A number acts on space, it changes it. Positive number preserve orientation while negative number reverse it. So to see this clearly, imagine a number line, 0 at the center. Positive numbers extending right while negative numbers extending left. This is not an arbitrary notation, it is geometry. Every number carries orientation. Positive means agreement with the chosen direction while negative means opposition to it. And multiplication acts on that geometry. When we multiply by 2, every distance doubles. The line stretches. When we multiply by 1/2, every distance shrinks. The line compresses. But when we multiply by -1, something fundamentally different happens. The line reflects through 0. Every point jumps into its mirror image. Left becomes right and right becomes left. Orientation is reversed. This means multiplication is not simply repeated addition. That interpretation breaks the moment negative appears. Multiplication is transformation. It changes both scale and orientation, and that is its true nature. And once we accept that, the mystery of squaring begins to clarify, because squaring is not just a number times itself. That phrase hides too much. Squaring is a transformation applied twice, and repeated transformation behave in ways that reveal deep symmetry. Take multiplication by -3. At first glance, it seems like one operation, but it's secretly two. First, stretch by a factor of 3. Second, reverse orientation. These are distinct actions. Scale, then reflect. The minus signs handles orientation. The magnitude handles size. So this decomposition is everything, because now we can ask, what happens when we repeat it? Apply -3 once. Space stretches and flips. Apply it again. It stretches again and flips again. The scaling compounds. 3 becomes 9. The reflection compounds too. And here is something profound happens. A reflection performed twice is not more reflected. It becomes identity. The reversal undo itself. The line returns into its original orientation. So the second reflection cancels the first. This is not arithmetic convention. it is geometry necessity. A mirror reflected in another mirror restores what was first observed. This is the law of symmetry, and this law forces positivity, not by definition, not by memorization, but by structure. Negative times negative become positive because orientation reversal is a self-cancelling under repetition. And that same structures explain squaring. When a number squares itself, it repeats its own orientation. And if that orientation is negative, the reversal happens twice. And two reversals cannot remain feasible. They collapse into restoration. The direction does not disappear by force. It disappears because symmetry leaves no trace. Now, we can face the central mystery directly. Why do positive theory and negative theory produce the same square? The answer lies in what squaring chooses to preserve. Squaring preserves scale growth. It does not preserve orientation. Why? Because orientation is first order information. It tells us which way something points. But squaring is second order. It measures what happens when transformation compound with itself. And under self-composition, orientation loses individuality. A single reversal is distinguishable. A double reversal is not. This is one of mathematics' deepest symmetries. Opposites often disappear when composed evenly. A left turn followed by a left turn is indistinguishable from a right turn followed by a right turn if both complete a full rotation. The intermediate direction differs. The final state agrees. This is exactly what happens with squaring. Positive and negative begin differently, but after two applications, they converge. Their paths are opposite. Their destination is identical. Squaring reveals what remains after orientation has extinguished itself. It extracts the inverse beneath directional difference, and inverse is one of mathematics' most powerful ideas. It is what survives transformation, and it is what remains true no matter how perspective changes. Squaring strips away what depends on orientation and leaves only what is absolute, magnitude itself. There is another way to say this, and it is impossible to ignore. What is a square? It is area. Take a side length of 3. Its area is 9. Straightforward. Now, assign the side length -3. What should happen? Because if negativity preserves direction inside area, the square will somehow point backward. But area cannot point. Area occupies extent. It measures spreads across dimensions. Now, because direction is meaningful along a line. But once space unfolds into area, orientation becomes irrelevant. So, the second dimension destroys directional dependency, and area remembers size, not sign. This is not a rule humans invented. It is built into geometry itself, because if negative length produces negative area, geometry will become contradictory. Regions will need orientation to exist, but ordinary Euclidean area has no such structure. It only measures how much space is enclosed. This is why squaring possesses positivity, because the moment one-dimensional direction becomes two-dimensional extent, orientation dissolves into magnitude. The square forgets which way its sides were traced. It remembers only how much space they define, and that is not accidental. It is one of the cleanest examples of dimensional changing what information survives. The same principle appears everywhere in physics, not as coincidence, as necessity. Velocity can be positive or negative. Direction matters, but kinetic energy depends on velocity squared. Why? Because energy measures capacity to produce change, not orientation. An object moving east at 10 meters per second carries the same kinetic energy as one moving west at 10 meters per second. The universe does not care which way it moves when measuring energy, only how intensely it moves. Direction disappears and magnitude remains. So, the same happens in electric field, wave amplitude, statistical variance, and distance formulas. Again and again, whenever reality cares about intensity rather than orientation, squaring appears. It is mathematical universal way of saying forget direction, keep strength. And that is why squaring dominates science. They isolate what survives reversal. They reveal what remains unchanged when orientation flips. and invariance under reversal is often the deepest physical meaningful quantity. So we return to the original mystery. Why does squaring destroy direction? It does not. That wording is almost right, but not quite. Destruction implies its loss, and nothing is lost here. Direction is not erased, it is completed. A negative orientation apply once creates opposition. Apply again, it resolves into agreement. Squaring does not discard the negative sign, it lets it finish its works. And once that work is completed, orientation has nothing left to say. What remains is pure magnitude, the quantity beneath perspective, the structure beneath direction, and the invariant beneath opposition. This is why two opposite numbers can produce the same square, because squaring is not interested in their disagreement. It is measuring what survives beyond it. And that is one of mathematics' quiet miracles. What appears opposite at first can reveal deep unity when symmetry is allowed to finish. That tiny equation negative times negative equals positive was never just arithmetic. It was the shadow of profound geometric truth. The truth hidden in plain sight. That under perfect symmetry, opposition does not vanish. It resolves into harmony. If you like this, make sure you like and subscribe for more, and I hope to see you next time.